Good morning students. Today we are going to see scattering of light in chapter 2 optics. Scattering is the process in which electromagnetic radiation or particles are deflected or diffused. Scattering of light is the phenomenon in which light rays get deviated from its straight path on striking an obstacles like dust or gas molecules, water vapors, etc. Light is scattered when it falls on various types of suspended particles in its path. The phenomenon is named for Indian physicist Sir Chandrasekhara Venkata Raman, who first published observations of the effect in 1928. From this, let us see what is called scattering of light. When sunlight enters the Earth's atmosphere, the atoms and molecules of different gases present in the atmosphere refract the light in all possible directions. This is called as scattering of light. Here the beam of light is redirected in all directions when it interacts with a particle of medium. The particles molecules which scatter light are called scatterer. That is, the interacting particle of the medium is called as scatterer. Types of scattering. When a beam of light interacts with a constituent particle of the medium, it undergoes many kinds of scattering. Based on initial and final energy of the light beam, scattering can be classified as elastic scattering, inelastic scattering. What is called elastic scattering? The energy of the incident beam of light and the scattered beam of light are same. It is called as elastic scattering. Inelastic scattering. The energy of incident beam of light and the scattered beam of light are not same. It is called as inelastic scattering. The energy mentioned in both the elastic and inelastic scattering is kinetic energy. The scattering also classified based on the nature and size of the scatterer. They are Rayleigh scattering, Mie scattering, Tyndall scattering and Raman scattering. Now first we have to see about the Rayleigh scattering. Lord Rayleigh was the first to deal with the scattering of light by air molecules. Rayleigh scattering refers to the scattering of light off of the molecules of the air. This Rayleigh scattering is more effective at short wavelength. It is the phenomena of scattering of light particles majorly by the molecules of gas. From this we have to know that the scattering of sunlight by the atoms or molecules of the gases in the Earth's atmosphere is known as Rayleigh scattering. Rayleigh scattering law. This law states that the amount of scattering of light is inversely proportional to the fourth power of its wavelength. Amount of scattering S is proportional to 1 by lambda power 4. In this formula, scattering S is inversely proportional to the wavelength. So, the shorter wavelength colors are scattered much more than the longer wavelength colors. The blue appearance of sky is due to scattering of sunlight by atmosphere. When sunlight passes through the atmosphere, the blue color is scattered to a greater extent than the red color. This scattering causes the sky to appear in blue color. Why does the sun appear red at sunrise and sunset? During sunrise and sunset, the rays have to travel a large part of the atmosphere because they are very close to the horizon. Therefore, light other than red is mostly scattered away. Most of the red light, which is the least scattered, enters our eyes. Hence, the sun and the sky appear red. Mie scattering. Mie scattering takes place when the diameter of the scatterer is similar to or larger than the wavelength of the incident light. It is also an elastic scattering. The amount of scattering is independent of wavelength. What causes Mie scattering? Mie scattering is caused by pollen, dust, smoke, water droplets and other particles in the lower portion of the atmosphere. This scattering is responsible for the white appearance of the clouds. When light falls on the water drop, all the colors are equally scattered, which together form the white light. Tyndall scattering. An example for Tyndall scattering is when a beam of sunlight enters into a dusty room through a window, then its path becomes visible to us. This is because the tiny dust particles present in the air of the room scatter the beam of light. The scattering of light rays by the colloidal particles in the colloidal solution is called Tyndall scattering or Tyndall effect. Raman scattering. When a parallel beam of monochromatic light passes through a gas or liquid or transparent solid, a part of the light rays are scattered. This scattered light contains some additional frequencies other than that of incident frequency. This is known as Raman scattering. So, Raman scattering is defined as the interaction of light ray with the particles of pure liquids or transparent solids, which leads to a change in wavelength or frequency. Now, Rayleigh line. The spectral lines having frequency equal to the incident ray frequency. Raman line. The spectral lines which are having frequencies other than the incident ray frequency. Stokes line. The lines having frequencies lower than the incident frequency. The lines having frequencies higher than the incident frequency is called anti-Stokes lines. Thank you, students.